Let's get started. This is about section 4.4, counting rules. The fundamental counting rule says if you have n events of sequence, suppose if you could perform, in K1 possibilities for event 1 and K2 possibilities for event 2 and so on, then total number of possibilities for all the sequences of n events is simply the product of all the possibilities of individual events. Okay, so if you want to find total number of possibilities for all events n, simply multiply, the individual number of possibilities for all the events. So in our case here, simply find the product of K1, K2, and so on up to Kn. Okay, so the total number of possibilities here, total number of possibilities for n sequences of events is simply just find the product of, for each event, K3 and so on up to Kn. For example, a coin is tossed and a die is rolled. So we are performing two events here, tossing a coin and rolling a die. Find the total number of outcomes for this sequence of events. Okay. In this case, if you compare this with our fundamental definition, the number of events, little n here we perform is 2. And suppose if we denote K1 as the number of possibilities for event 1, my event 1 is the first event is tossing a coin. So there are two possibilities, either heads or tails. Therefore, K1 is 2. Suppose if we assume K2 as the number of possibilities for the second event, remember my second event is here rolling a die. So there are 6 possibilities. So K2 is 6. Therefore, total number of possibilities for both of the events, total number of possibilities, simply multiply these two numbers. So that is K1 is 2 times K2 is 6. So 2 times 6, which is 12. So there are 12 outcomes in total. Suppose if you want to find the sample space for these, two events, remember we had this same problem in first section we studied here. The sample space for these two events is nothing but tossing a coin. You may have from the coin you may have a heads, and from the die you may have number 1. So this is one of my outcome. Then H2 and so on up to H, 6. And we may have either tails and the number 1 from your die and so on up to T6. So in total, here there are 6 possibilities and here 6 possibilities. So in total, there are 12 possibilities. Okay. But in this particular problem, they are not asking us to find the sample space. They are just asking just the number of possibilities. So, but I have given here in detail about all 12 possibilities. Okay. Now look at the second example. The paint manufacturer wishes to manufacture several different paints, combination of paints. The categories include color, type, texture, flat, and the use. So there are 4 different, the things we have to consider. For each, you could think of these all 4 different events. Okay, so that means you need to perform 4 events. For each event, you may have here the number of possibilities. For example, if you look at the color, choosing a color, that could be, thought of your first event. So how many possible outcomes, how many possibilities I have for choosing a color? Well, I have 1, 2, 3, 4, 5, 6, 7. There are 7 possibilities, right? So therefore, here I have 7 possibilities. Here I have choosing a type of, the paint. I have 2 latex and oil. So there are two outcomes or possibilities. The next one I have, texture, flat. Texture is actually flat, semi-closed, high closed. So there are three. And the useness of this is there are two possibilities. Okay. So therefore, in total, if you mix all the combinations, so you will have different kind of the paint variety you will have. So the total number of different kinds of paint, the total number of varieties is simply here I have four events, right? So you could think of this as my K1, this is my K2, this is my K3, and this is my K4. So simply multiply all four numbers. So that is 7 times, 2 times, 3 times 2. So that is 84. That means there are 84 different possibilities you have to choose the paint variety. Okay. Okay. So next one. There's a note. Okay. Factorial formulas. For any counting number n, suppose if we have n the whole number, then the factorial of any given the whole number is given by n with this notation exclamation notation that is called the factorial notation. So factorial, so we use this notation. Okay. So in factorial means, simply what you want to do is you have to multiply numbers from 1, 2, 3, all the way up to n. So if it is n factorial, simply multiply 1 times, 2 times, 3 times up to n. Okay, for example, if you want to find the 5 factorial, what is 5 factorial? 5 factorial is simply 1 times, 2 times, 3 times, 4 times 5. Okay, so what is that? That is 120, right? So this is called the factorial. So this notation can be found in your calculator. So let me show that. So, suppose if you want to find 5 factorial, first simply type number 5, then go to math, and there you will find the PRB. Go to PRB, there you will find number 4. So that is a factorial notation in your calculator. Just enter, one more enter. So it is 120. Okay, so that's the way to find factorial. The next one, permutations. A permutation is an arrangement of n objects in a specific order. Suppose I'm giving you, say, 10 objects. In how many different ways you could arrange them? That is called permutation, the number of arrangements. Okay, so now look at this example. A person needs to make up 4-digit combinations to open the lock on the garage door. The person decides to use 4 different digits from the first 4 digits, 0 to 3. How many different combinations can be made? Okay. So what does it mean by that? That means he has to use the number from 0, 1, 2, 3. He could use these 4 numbers and he could put in any order. How many different ways he could make? That is called the permutation, the number of ways. Okay. So remember, to choose the first number, he has 4 chances, right? He could choose any 4. So you could think of the counting principle just now we saw. Here he has to choose 4 numbers. Therefore, the number of events here is 4. Okay. So event number 1 is simply choosing the first number. Remember, I am free to choose any number, among these 4. Therefore, the number of, the total possibilities, total number of possibilities That is called now the permutation for this problem. Okay. So that is simply now he has to choose four numbers. Therefore, the number of events is here four events. To choose the first event, he has four possibilities. He is free to choose, any of these four. Once he has chosen first number, now he cannot repeat that, right? All numbers should be different numbers. Now there are three numbers left over. To choose the second number, he has three possibilities. So to choose the second number, he has three possibilities. To choose the third number, he already chosen two numbers. The remaining two, there are two possibilities, and choose the last number, only one possibility. Therefore, total number of possibilities is 4 times 3 times 2 times 1. In factorial notation, this is nothing but 4 factorial, right? So that is how much? 24. So there are 24 different, combinations he could make, okay, by using all four digits once at a time. Okay. Now, to arrange these kind of things, so we have several rules. So here we are going to look at two rules. Rule number one, permutation rule number one. The arrangement of n objects, you are given n objects, but you need to arrange them order only by using r of them. That means basically you are not using all n objects. Instead, you are given n objects, of course, you are choosing r from them, right? Therefore, n is, the given total object, so this should be bigger than or equals to r. Okay, so you are choosing r at a time, and at a time, and it is called the permutation of n objects taking r objects at a time. So you are putting in order, right? So here order is matter. You are arranging in order. So order matters here. So you are arranging in order. In how many different ways you could arrange? The formula says that you could arrange in NPR ways. So NPR is just a number, just a whole number. So this will give you the number of total possibilities, right? For example, suppose say you are given five objects, and I'm asking you, hey, could you choose from these five, could you choose three? And in how many different ways you could arrange? That will give you idea of NPR. So the number of ways you could arrange is simply 5P R is now 3, so it is 5P3. Okay, so then how do you find 5P3? Formula says that, NPR is given by n factorial over n minus r factorial, right? In this case, how do you find then 5PR? Simply n is now 5, 5P3, I'm asking. So r is 3. Simply plugging these two values instead of r and n. So my n is now 5. So this is 5 factorial. Okay, 5 factorial over 5 minus 3 factorial. So that is 5 factorial over 5 minus 3 is 2 factorial. Okay, so now you could use the calculator. I have shown you how to use, the factorial notation. So find the answer for 5 factorial. Earlier we saw 5 factorial is, 120. And find 2 factorial. 2 factorial is 1 times 2, which is 2. So 120 over 2. So 120 over 2, what is that? So 5 factorial is 120 over 2 factorial is 2. So it should be 60. 16 different ways. So you could arrange, 3 objects from 5, choosing 3 objects at a time and putting into order. Okay, so but the one thing is, you have one more option. You could find 5P3 without using this formula. So you have directly typing, option in your calculator. So how do you type 5P3 instead of using this formula? So let me show you. So if you want to find 5P3, first type 5 Then go to math, the number 4, PRB, and you see NPR, the option number 2. Type that, enter. Now type the second number 3, then enter. That is 60, no? So 5p3 is 60. So you could use either this formula directly or the formula I have given you. So that's up to you. So there are 60 ways. Okay, the next one. A radio talk show host can select 3 of 6 special guests for her program. The order of appearance is important now. She wants to put in order, right? She wants to choose 3 at a time and putting in order. How many different ways this can be done? So therefore, the given total number of object is 6. So the object she wants to select is 3. Therefore, total number of ways is simply 6p3. So you could use either calculator and type this directly or the formula I gave you. So I'm using NPR is n factorial over n minus r factorial. So let me write down one more time here. NPR is n factorial over n minus r factorial. So my n is now 6. So I'm replacing 6 here over 6 minus r is 3 now factorials. That is 6 factorials over 6 minus 3 factorials. So that is 6 factorial over 3 factorial. So 6 factorial over 3 factorial. So if you find this number, you could type now 6 factorial over 3 factorial. So you don't need to find one by one if you want. You could type all at a time into your calculator. So first I'm typing 6 factorial, 6 math PRB factorial. Now I'm going to divide this number by 3 factorial, so which is 3, and again go to math and factorial number 4. So 6 factorial over 3 factorial is 120. That means what? That means there are 120 ways, so she could choose, 3 at a time and put in order from 6. So that is called the permutation. So the next rule number 2. The rule number 2 says that the number of permutations of n objects, right, when R1 objects are identically same and R2 objects are identically same. So there are several number of objects they are repeating, right? So up to P objects, there are RP ways, several ways. So you could choose the different numbers, 3 different numbers, but each number has, R of them identical. So then how many ways you could choose, you could choose arranging in all, by using all the numbers, all P different numbers, in how many different ways you could arrange. So the formula says that is n factorial over R1 factorial times R2 factorial and so on up to RP factorial. Okay, so let me explain these concepts by using this example 5. Okay, so let's look at this problem. How many permutations of the letters can be made from the word statistics? So by using this, all the letters, how many different, words you could make? Okay, so now first you, identify what are the letters it is given, different letters, S, T, we have A, I'm right, looking for all different letters. So then I have I and I have C, right? So these are the different letters I have. Okay, now count to how many S repeating here. Okay, S appears 1, 2, 3, 3, and the T appears in 1, 2, 3, again 3 places, and the A appears only 1, and I 1, 2, and the C appears only once. So like that, you count, the number of ways. You could think of this as, R1, this number is my R2, this is R3, this is R4, and this is R5. That means what? That means I have 5 different letters. You see here R5. So I have 5 different letters in statistics. Each letter appears this much times, right? R1, R2, R3. So the question is now, how many different, words you could make here? The number of words you could make by using all the letters, right? This much ways, all the letters. So it will give you, n is here what? N. N is the total number of letters, in this word. So in total number of letters is simply add these all numbers. 3 plus 3, 6, 7, 9, 10. There should be 10 total letters in this word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is 10. So how many different ways I could make? The number of ways we could make the words, the number of ways I could find the letters, you know, I could find the words from the different letters, putting these all letters in different ways. So that is simply n factorial. I'm using this formula, right? So n is now 10, so which is 10 factorial over. Okay, let us put one by one. S appears 3 times, so it is 3 factorial times. T appears again 3 factorial, and A appears only 1 factorial, and I again 2 factorials, and C again 1 factorials. So you could type this all, by using the calculator at a time. You don't need to type one by one. You could type all at a time, okay? So if you want, I could show you. So I'm going to type this all at a time. So make sure that you are putting parentheses for numerator and denominator. So I am first putting the parentheses and typing 10 factorials. 10 math factorials. Closing the parentheses, then I'm dividing and opening the parentheses for the denominator, and I'm going to type this all. So 3 factorials, 3 factorials. Of course, that is 6, but I just want you to, show you how to type. So 3, then times means multiplication, and the second number again 3. So again I'm typing 3, and again I need factorials. Then again times 1 factorial is we know that is 1. So 2 factorial is 1 times 2. That is again 2, and 2, and again 1 factorial is 1. So simply close that. So that is 50,400. Oh, that is a big number, right? That means you could find 50,400 different words, if you use all and putting into different order. Okay, so that is there. Okay, let's move to the next rule, which is called the combinations rule. The number of combinations of R objects selected from N objects. Again, you are given N objects. You need to choose R at a time, but this time you don't put into order, right? Order is not important. Simply, you need to look for different combinations. So suppose if you are given 5 objects, I'm asking you, hey, in how many ways you could choose 2 from them, how many different ways. You don't need to put in order all 2. So simply picking, right, different combinations. So when you use the combination rules, you have to keep in mind that order is not important, right? Order is not important. You are not putting into order. Right? Remember, in NPR formula, order is important, right? You are choosing R objects from N objects, and you are putting all, into order. So here order is not important. If order is not important, in how many different ways you could choose R objects from given N objects, which is simply called NCR, or you could read like N choose R, N choose R. N choose R is given by simply N factorial over, so NCR is simply N factorial over N minus R factorials times R factorial. Okay, so this is the formula for NCR. Remember, for NPR, we have simply just N factorial over N minus R factorial. You don't see this extra factor in NPR formula. So that's the difference between NPR and NCR. Okay. So before going to apply the correct formula, ask yourself whether order is important. If order is important or you are putting into order, then use NPR formula to find the total number of ways. So if you want, you know, to put simply choosing, then use NCR. Look at this problem. How many combinations of four objects are there taken two at a time? You are given four objects, so my n is now four. So you need to choose R. You need to choose two at a time. But remember, they are not talking about the order, right? Simply choosing. So that means you need to use the number of ways. The number of ways choose could choose, 4CR, 4C two ways, right? Because I'm using combination formula. So what is 4C2? Well, if you use this formula, 4C2 is my n is 4 and r is 2, simply plugging those two values into your formula. So this will give you 4 factorial over 4 minus 2 factorial, then times r is again 2 factorial. So if you simplify this, 4 factorial is 1 times 2 times 3 times 4, which is how much? 24 over 4 minus 2 is 2 factorial, again 2 factorial. So that is 24 over 2 factorial is 1 times 2, which is 2. And again 2 factorial is 2. So this is 24 over 4, that is 6. That means there are 6 different ways you could choose, two from 4 objects. Okay. But anyway, again, you could type this 4C2 directly without using this formula. So you could use calculator as well to find 4C2. So let me show that also. First type 4, then again go to math, and number 4, you see now 4CR formula is number 3. So type number 3. So 4C, my R is now 2, type just 2. So that will give you 6. So that's the way to use calculator also. Okay, so now this question is quite different. In a club, there are 7 women and 5 men. A committee of 3 women and 2 men is to be chosen. Oh, you are given in total there are 12 people, right? 7 women and 5 men. You need to choose 3 women from the 7 and 2 men from 5. And how many different groups you could make? Are they talking about the order? Order is not important. You need to choose, just choosing different groups they're talking about. Okay. But here, you need to use first counting principles at the beginning we saw today. So how many tasks do you have? You have 2 tasks now, right? Choosing a woman is my first task, and choosing a man is my second task, right? So you have 2 tasks now. Therefore, my n is 2. So remember, you need to now find. So remember, you need to you know find what is n. N is the total number of events now you are making. So you have to make 2 events now. Therefore, n is 2. Now you are asked to find first K1 and K2. K1 is the number of possibilities for my first event, first task. Remember, my first task is choosing women, right? You are given 7. You need to choose 3 from them. So how many different ways you could do that? I could do that in 7, choose 3 ways. So that is my K1, choosing 3 women from 7. Order is not important, so I could find 7, choose 3 different combinations to choose 3 women from 7. Similarly, my second event is going to be what? Choosing men. So we need to choose 2 men from 5. Therefore, the number of ways I could choose is 5C2, right? Therefore, the total number of ways is simply find the product of these two, K1 times K2. So my K1 is now 7 choose 3 times my K2 is 5, choose 2. Now take your calculator and find these numbers and multiply them out. So that is goal. That is my final answer. So remember, first time using what? Remember, first time using counting principles. First use counting principles to identify and then the K1, K2. Okay. Then you need to go for what? Then you need to go for combination formula. So you have to combine both this time because you are performing more than one event. Okay. So find these two numbers. So you have a calculator and simply find those two. So 7 choose 3. 7 choose 3. So go to math. 7 choose 3. Then times 5C2. 5 5 C2, right? So it is 350 ways. So I have summarized everything under one table. So the first we saw counting principles. So that is my first, the number of ways we found today. After that, we saw the permutation formula. The permutation formula is important when you have order. Then we saw how to arrange, p different objects. Each object has different kind of similarity. Then you have to use the permutation rule number 2. Then we had the combinations formula. The combination formula in CR is given if you choose R objects from N objects, but order is not important. You are simply choosing, right, different combinations. So then use NCR formula. So try to, differentiate these 1, 2, 3, 4 scenarios and make sure that you understand the concept of, each counting principles and make sure that you put in correct place all numbers. Okay, so that is the thing here we need to look at, then go for this exercise.